Find f prime of x and its interval of convergence for f of x equals sum n equals 0 to infinity, negative 1 to the n plus 1, x minus 5 to the n, over n times 5 to the n. So f prime of x can be done simply by term differentiation. Remember, all the n's are constant. So we get sum n equals 0 to infinity, negative 1 to the n plus 1, multiplied by n times x minus 5 to the n minus 1, all divided by n times 5 to the n. And a little housework, the n's cancel. Now, in the last exercise, we showed that the function f had interval of convergence (0, 10). So that means f prime of x is going to converge on 0, 10 also, except we might have some change of information, lose or gain, at the endpoints. So therefore, we're going to plug in the endpoints here. If x equals 0, then what we end up with is sum from n equals 0 to infinity, negative 1 to the n plus 1, and then negative 5 to the n minus 1. So that's going to be negative 1 to the n minus 1 times 5 to the n minus 1 over 5 to the n. So this is going to be negative 1 to the 2n, which is just 1. So essentially we can cancel these off. And moreover, 5 to the n minus 1 is going to cancel with a 5 to the n on bottom, just leaving us a factor of 5. So we get the series sum n equals 0 to infinity of 1 over 5, which, if you add up 1/5 plus 1/5 plus 1/5 infinitely many times, the series diverges. Now, if x is equal to 10, then we have negative 1 to the n plus 1, summation from n equals 0 to infinity. 10 minus 5 is 5 to the n minus 1 over 5 to the n, which cancels, leaving us a factor of 5. And so we get the series sum n equals 0 to infinity of negative 1 to the n plus 1 over 5. So if you start off with 0, then you get negative 1/5 plus 1/5, negative 1/5 plus 1/5, and this series alternates between negative 1/5 and 0 with its partial sums, and therefore this diverges also. Hence, our interval of convergence for the derivative is just 0, 10.